Hello, everybody. This is Laura Doherty from Functional Formularies. Thank you so much for joining us today for our webinar titled From Kitchen to Tube, Making Mealtimes Normal with Whole Food Formulas. Just a few housekeeping things before we get started. Everybody is on mute, and please remain muted throughout the webinar presentation. We will have time for some Q&A at the end of the presentation, but if you have questions throughout the presentation, please go ahead and put them in the questions section of the GoToWebinar panel. And if there's some of them that I can answer while Leila is talking, I will do that. If you have any tech issues, we'll try and work with you through that as well. So feel free to use that question function throughout, but we will try and get to as many Q&As at the end of the session. This has been approved for one continuing professional education unit through CDR. So after the webinar, you will get an email that has your certificate, the references, and a copy of the slides. So that email comes separate. It will not automatically pop up at the end. It's a separate email from us at Functional Formularies that will have all that information. If for some reason you do not receive that email by the end of the day, please let us know. You can email me at laura@functionalformularies.com, or you can contact us through our website as well. So I want to make sure you get your certificates. This is a two-part series, but if you're only tuning in for this one, it's no worries. This is fully comprehensive by itself as well. But if you missed the first part of this series, which was last month, it was titled Mealtime Matters, Implementing Everyday Eating for Tube Feeding. It is available as a recording on our website. So if you go to functionalformularies.com and go to the Continuing Education Center, you can access the first part of this series. But again, they are also very much standalone webinars. So if you missed that one, no worries, you can go back and watch it. It is available for one CPE in the recorded version. So with all that being said, I want to start by introducing our co-collaborator, Fred Roying from You Deliver Medical, to introduce himself and give you a little detail about what they do over at You Deliver Medical before we start with the presentation.
Hi, thank you, Laura. And I'm Fred Roying. I'm one of the co-founders of You Deliver Medical. We are a medical device company that makes feeding tube delivery systems specifically for the home-based patient, our bully bag and bully caps. We're pleased to co-sponsor this or collaborate with Functional Formularies on this. It's important information, and Leila is going to do a great job like she did the last time. I hope you enjoy and learn something. Thank you very much.
Thank you, Fred. All right, and so our presenter is Leila Thorne. She's a dietitian with over 15 years of experience, including more than a decade specializing in pediatric nutrition in both the acute care and outpatient settings. From neonatal intensive care to young adults, Leila has seen it all. As an international board certified lactation consultant, she is committed to promoting optimal nutrition from the start of life. Her background includes a BS in exercise science and a dietetic major, completed through the dietetic internship program at WSU. She is actively pursuing functional medicine to complement her dietetic background to gain a better understanding of root disease dynamics to support optimal living with evidence-based science. So Leila, thank you so much for doing the past one and for joining us again for this one. It's been truly a pleasure getting to know you through this, and I'm excited for what you have to share with us today. So I will stop talking and let you do your thing.
Thank you so much, Laura. I appreciate that warm welcome. All right, so let's see here. So now we all understand the importance of whole food to support overall health, and on the contrary, how many processed foods can be detrimental to health. So today we're going to be doing a deeper dive, not only into how whole foods nourish our gut, but also how many ingredients in highly processed foods are contributing to gut inflammation and dysbiosis, and how we can apply this evidence when selecting enteral formulas to hopefully nourish our patients. Now here are my disclosures. So at the end of this presentation, I really want you to be able to identify optimal fuel for our microbes that benefit not only our gut health, but also our systemic health. Also recognize the vitamins that support our microbiome. And finally, understand 2 ways whole foods can support a healthy gut mucosal layer. So to give a brief overview, our gut microbiome refers to all the microbes in our intestines. And there's thousands of different species and even subspecies of these bacteria, yeasts, fungi, parasites, and archaea. They're all competing for space, food, and nutrients. It is basically our own little ecosystem that has a tremendous potential to impact our physiology. Our gut microbiome contributes to metabolic functions, it protects against pathogens, and even educates our immune system. Now, in a healthy person, these microbes coexist peacefully throughout the body, the largest numbers being found in our small and large intestines. And as you can see from this picture, these are just some of the more common and identified bacteria colonized within our gut. And the reason I say our own ecosystem, because each of us have an entirely unique network of microbiota that is actually determined by our DNA. We are first exposed to microorganisms as an infant during delivery via the birth canal and also through breast milk. And by the age of 2 or 3, that bacterial composition and diversity of our microbiome is that most like ours as an adult. But environmental exposures, antibiotic use, and our diet can change our microbiome to either benefit our health or place us at a greater risk for disease. So as a quick refresher, let's break down how the intestinal barrier supports our immune system and interfaces with our microbiota. So our intestinal mucosal layer is our first line of defense when it comes to our luminal microbiota. This mucosal barrier acts as a protective barrier to trap bacteria and prevent unwanted contact with our epithelial cells. The goblet cells within the epithelial cells are the main producers of mucin, which is the foundation of our mucus layer. And by design, our small intestine actually only has 1 layer of mucus, where our colon has 2. And the reason for that is the majority of our nutrient uptake from digested food occurs in our small intestine. So that's probably the likely reason that we have a more penetrable mucus layer in that region, whereas the colon, the inner mucus layer in there, is actually sterile, while the outer mucus layer harbors the intestinal microbiota. So our epithelial cells are those tight junctions that form semi-permeable structures to allow the uptake of essential nutrients for immune surveillance. But it is also restrictive against pathogenic molecules and bacteria. Now, the intestinal barrier is constantly interacting with the gut microbiota, influencing immune cell development and function by producing metabolites like short-chain fatty acids. And these can promote immune homeostasis. So the intestinal epithelium is densely populated with immune cells, which are constantly monitoring the gut lumen for potential threats and innate immune responses when necessary. So we want to start to paint this picture of a mutually beneficial symbiosis, where microorganisms derive benefit from their hosts by inhabiting a protected, nutrient-rich environment. And in return, these bacterial populations make a number of key contributions to the health of the host. So let's walk through this illustration here. So looking at the left side of the screen, that represents a healthy gut. Now this is a pretty simplified illustration of what appears to be a small intestine. And here you can see some antimicrobial peptides and secretory IgA molecules that are secreted in the mucus layer, as our immune sensing and regulatory proteins. And then we've got our intestinal epithelial cells, which appear in this continuous single layer. And as you can see, they're tightly attached by junctional complexes like our tight junctions, which regulate the transport of small molecules. But what's not pictured, let's see, it's not pictured, but we do have some immune cells within the epithelial cells that take part in our immunological defense mechanisms of this intestinal barrier. Now, as we move along into the middle third of this illustration, we see the imbalance of gut flora or dysbiosis that can damage the small intestine lining. And dysbiosis essentially describes an imbalance of the gut microbiota, disrupting the normal relationship between the host and its microbial community. And here's why we're so concerned about this imbalance. Because dysbiosis can contribute to the onset of chronic disease. Dysbiosis generally occurs in one of three ways. So we can have a loss of beneficial organisms, a decrease in overall microbial diversity, or an excessive growth of potentially harmful organisms due to the suppression of health-protecting bacteria. And these types often occur simultaneously. Dysbiosis has been implicated in a wide range of diseases, including intestinal diseases, metabolic diseases, and even neurological or neurodevelopmental issues. At this time, it is unclear if the unbalanced microbiota is a causative factor or the effect of the condition. We know that patients with IBD have shown a characteristic pattern of decreases in commensal bacteria diversity, while patients with type 1 and type 2 diabetes although they're caused by different mechanisms in the body, studies have found both types to have dysbiosis in the intestinal microbiota, which may contribute to the pathogenesis of this disease. Both are associated with a decrease in overall microbial diversity, as well as a breakdown of the epithelial barrier integrity and increased gut permeability. Obesity has long been considered an imbalance of energy, where we have low energy expenditure plus higher caloric intake. However, recent evidence suggests that obesity is even a more complicated disease associated with intestinal dysbiosis. Now we also know, along with these conditions comes chronic inflammation, which can exacerbate dysbiosis and further damage the gut lining, disrupting the balance of the microbiota and creating a vicious cycle. As we pointed out, chronic inflammation can be a vicious cycle within the gut if the underlying cause isn't corrected, because over time it's likely to lead to enhanced intestinal permeability and a dysregulated immune function if it's not corrected. We're going to see a potent inflammatory mediator triggered to up immune reactivity and intensity. So like I did mention in our first webinar, we recognize that any type of stress, whether it's perceived or real, external or internal, can actually reduce mucosal blood flow and result in impaired intestinal barrier function. And if we're degrading or eroding our protective mucosal barrier, we're also allowing things that shouldn't be allowed into our lymphoid tissue of the gut or even leak into our blood supply, triggering an even stronger immune response. So let's look back at this illustration where we see the progression of erosion of the mucosal layer. So when we have dysbiosis and barrier disruption, this can lead to permeability defects, allowing interaction of intestinal immune cells and with the luminal contents. Activated immune cell release is pro-inflammatory cytokines such as tumor necrosis factor, and in turn, tumor necrosis factor results in tight junction disruption and intestinal epithelial cell apoptosis, which exacerbates local inflammation. Now, this damage to the protective intestinal mucosal layer or enhanced intestinal permeability can be caused by a variety of factors like chronic inflammation, pathogenic infections, overgrowth, certain medications, stress, or even dietary changes. Increased permeability, so this allows undigested food particles, bacteria, and toxins to leak into that bloodstream, triggering inflammation and immune responses. Long-term consumption of processed diet can also drive intestinal barrier permeability. Now, I understand that in our modern fast-paced world, it's probably not a simple solution to avoid all highly processed foods. But part of our role as dietitians are to be educators of nutrition. We must teach what the evidence reveals to our clients to make informed decisions. So when we're looking at the frequency of exposure, what does that look like for a person that is 100% tube dependent? Let's start off by talking about carrageenan. So some of you may know that it's an actual extract of red seaweed, therefore considered a natural food ingredient. It's widely used in the processed foods, including commercial liquid tube feeds for several properties, including stabilization, emulsification, and improved mouthfeel or overall texture. Back in the 70s, the daily intake of carrageenan from food in the US was estimated to be about 100 milligrams per day. But the use of carrageenan as a food additive has substantially increased, and now it's estimated that we are consuming about 2.5 times that. Carrageenan is one of the most frequently consumed food additives when looking at a diet of a pediatric population with irritable bowel disease. We have several in vitro studies that reveal that carrageenan is able to induce inflammation, triggering innate immune pathways. Now, even more interestingly is that this pro-inflammatory activity is so well understood that carrageenan is actually used as an inflammatory and adjuvant agent in experimental models to investigate immune processes and assess the activity of anti-inflammatory drugs. Studies conducted in mice demonstrated that carrageenan not only induces intestinal inflammation, but also significantly alters gut microbiota composition. Previous studies also show that carrageenan can inhibit gastric juices and pepsin, compromising the digestion of proteins. Now, just like in every situation, we do have to recognize that every individual is unique, right? So N equals 1. So while individual reactions can be dependent, individual reaction to ingested carrageenan can really depend on the conditions of the gastrointestinal tract, including the stomach acidity, mucosal integrity, and even previous gut damage. So here's an illustration where carrageenan is seen triggering the activation of the immune system. So we have our our toll-like receptor 4 activation, which is crucial for initiating an immune response and the development of inflammation. We see alterations in the actin filaments, or in this case, the microvilli, leading to the disruption of intracellular junctions between adjacent cells and reduced barrier function. Now, carboxymethylcellulose is also another food additive, and it's typically derived from wood pulp or cotton lint to create a gum for thickening and emulsifying food products. So just like we saw in carrageenan, cellulose gums are also used to develop intestinal inflammation in animal models. And because carboxymethylcellulose isn't digested, the FDA actually classifies it as a dietary fiber on food labels. But we're going to see later that cellulose gum is actually not a microbiota accessible carbohydrate. Now, in animal studies, even relatively low concentrations of this induce low-grade inflammation and obesity and even metabolic syndrome. Those treated with cellulose gum were noted to have significantly decreased in mucosal barrier by about 50%. And in this study, carboxymethylcellulose dramatically altered microbiota composition in both fecal and intestinal adherent bacteria. The authors concluded that the chronic exposure of carboxymethylcellulose resulted in erosion of the protective function of the mucus, increased bacterial adherence, and a more pro-inflammatory microbiota. The authors also looked at a mucosal simulator of the gastrointestinal microbial ecosystem model to examine the effects of these emulsifiers on the human microbiota in vitro. And carboxymethylcellulose in particular acted upon human microbiota to increase its pro-inflammatory potential. So even the effects were noted after one day, and these effects were driven by altered gene expressions of the microbiota. Oops, let's see here. All right, so high fructose corn syrup has been shown to reduce beneficial butyrate producing bacteria and alter the gut microbiota profile that may affect host lipid metabolism. What's interesting is that high consumption of fructose from fruits seems to balance the composition of the gut microbiota in a beneficial way and support digestive health, counteracting harmful effects of excess fructose. Now, we all see the negative impacts on the gut in both low and high levels of artificial sweeteners. In particular, aspartame and saccharin were found to induce cell death in intestinal epithelia concentrations, while even at low concentrations, these artificial sweeteners and sucralose increased in epithelial barrier permeability. So let's take a look at some of these ingredients in tube feeding products when it comes to food additives that we just discussed. Our patients on these products are by no means receiving low concentrations of these food additives, just based on the nature of their full dependence on these products. Oftentimes they're taking several containers of these a day. So here I've pointed out some different food additives and different sources of carbohydrate. So here I've got corn maltodextrin, which is used as our primary source of carbohydrate. There is some fiber in here, which is derived from soy. And then further down, you can see the natural and artificial flavors, along with several forms of emulsifiers. This one is similar, but along with with those emulsifiers, we also see cellulose gum. Now, what I find really ironic about this particular formula here, it's an unflavored peptide formula. So more likely than not, it's going to be delivered via a feeding tube. But what's ironic is that it contains an artificial sweetener. And for our last comparison, here is a whole food blend. No emulsifiers or stabilizers, no artificial sweeteners or natural and artificial flavors. And even if you look back between this one and the others, even the vitamin blend is less extensive because most of the micronutrients are coming from whole foods, which are naturally more bioavailable than the vitamins fortified in the previous examples. So remember that choices matter for the health of our patients, whether they're eating by mouth or through a tube. Now, food intake and dietary habits can have the most prominent influence on microbial richness and composition. Remember, microbes must be fed. They survive on our residue. And diet plays a role with regards to inducing or even reducing systematic low-grade inflammation because it can have both a direct and indirect effect. Diet supplies nutrients and bioactive compounds that modulate the inflammatory response and indirectly affect our weight gain. So the Mediterranean diet is just a great example of polyphenols and dietary fibers. It's characterized by a high intake of fruit, vegetables, legumes, whole grains, nuts, and seeds. Polyphenols are present in many foods, including fruits and vegetables, and usually arrive in the colon intact, where they can have regulatory functions and antimicrobial properties that modify the gut microbiota. Observational studies suggest an inverse association between dietary phenol intake and the risk of cardiovascular disease, inflammatory and metabolic disorders, and even some types of cancers. Furthermore, fibers can lower the glycemic load of meals by slowing down carbohydrate uptake and play an important role in gut microbiota modulation via certain non-digestible fibers that are fermented or are short-chain fatty acids. The dietary pattern revealed an overall reduction in the oxidative stress concentration and a reduction in pro-inflammatory markers. Additionally, there was an increase in antioxidant concentration and an increase in anti-inflammatory markers. On the contrary, studies on Western and fast food diets report higher levels of oxidative stress and higher levels of inflammatory biomarkers. Now, the role of fiber has been discussed for decades. This paper actually references a study from the 1960s with regards to a high fiber intake and its inverse relationship on disease states. So my question is, if we've had this information since the 60s, why hasn't the standard US dietary guidelines changed for fiber? Here we see the individuals in rural populations in Africa were consuming between 60 and 140 grams of fiber daily. Western diets back in the 60s and 70s averaged about 20 grams of fiber a day, which that on average is still more than the average adult consumes today in the US. Now, they didn't quite understand the mechanism as to why a high fiber diet was significant in lowering the incidence of disease, but recent studies suggest that the explanation of the beneficial effects of dietary fiber is attributed to fermentation by the gut microbiota. So as we talked about, diet is one of the most important influences on homeostasis of gut microbiota. Remember, those microbes must be fed and they must survive off of residue from our diets. Carbohydrates for gut microbiome fermentation can come from a variety of sources. Today, we're just going to focus on those that come from dietary plant sources. Now, we must recognize that not all fiber is actually created equal. So today, we're going to talk about certain non-digestible fibers as microbiota accessible carbohydrates. Because unfortunately, a large portion of non-digestible carbohydrates in whole grains are actually not metabolically available to gut microbes for fermentation. So while the dietary fiber may add bulk to our stool, it's not actually necessarily feeding our microbes. And individuals consuming majority of their dietary fiber from those sources may not see the desired benefits of a high fiber diet. But a diet rich in microbiota accessible carbohydrates promotes the growth of beneficial gut bacteria that can ferment these microbiota accessible carbohydrates into short chain fatty acids. So in people consuming a high plant-based diet, there was an increase in short chain fatty acid levels and a reduced short chain fatty acid levels in people consuming a Western diet. Now here's where we come full circle with the synergistic benefits of our gut microbiota. Because the more microbiota accessible carbohydrates we provide, the more diverse populations of bacteria we see in our intestines, which helps support a strong mucosal barrier in the gut. In preclinical studies, low consumptions of microbiota accessible carbohydrates over generations leads to a complete disappearance of beneficial bacterial strains. While this study has not been carried out by humans, it is known that similar to mice, low dietary microbiota accessible carbohydrates decrease bacterial diversity. This seems to suggest that the long-term reduced microbiota accessible carbohydrate consumption over generations will likely have a detrimental effect in humans. Now, I find this quite alarming, but also quite preventable. Short-chain fatty acids are synthesized in the colon during the process of dietary fiber fermentation. And as you can see from this illustration, they play a crucial role in overall gut health, energy metabolism, and even immune function. The most common short-chain fatty acids include acetate, propionate, and butyrate. They are a source of energy metabolism for colonocytes and support gut barrier function by promoting proliferation of epithelial cells to help repair tissue and prevent inflammation. In obese individuals, the level of short-chain fatty acids are significantly decreased when compared to lean individuals. Now, the decrease of short-chain fatty acids may be due to increased short-chain fatty acid absorption, as well as the altered composition of intestinal microbiota, which shows a decrease in butyrate-producing bacteria. Short-chain fatty acids are believed to inhibit the accumulation of fat in adipose tissue, so a decreased level is thought to contribute to obesity. So we're going to spend a little bit of time talking about butyrate because during the first 1,000 days of life, the infant's gut microbiome is still developing, and the presence of butyrate-producing bacteria is crucial for establishing a healthy immune system. We know that breast milk contains a significant level of butyrate, which may contribute to the development of immune tolerance in infants. In particular, butyrate is thought to be a protective against the establishment of potentially pathogenic intestinal bacteria, which indicates that short-chain fatty acids may be a regulatory factor in the origin of dysbiosis. Now, not only do we need to feed our microbes fuel, but specific vitamins also support our microbiome. We see here in this illustration that vitamins can beneficially modulate the gut microbiome. We have B vitamins that act as essential cofactors in bacterial metabolism to support microbial diversity, while vitamin C supports the increase of short-chain fatty acid production. We also see correlations with increased barrier function and overall immune function. A diet deficient in vitamin A, we see alterations within the commensal bacteria and impairments to the intestinal barrier just within a few weeks. Vitamin D seems to play a role in intestinal barrier. It promotes epithelial cell resistance to injury and suppresses inflammatory responses. Vitamin D is also believed to be a factor in regulating gut bacterial homeostasis. And a vitamin D deficiency is often characteristic of people with irritable bowel disease, and there's actually a correlation with the severity of the disease. Now, gut microbes also contribute to vitamin synthesis, but unfortunately, the production of these vitamins varies greatly based on the health of the host. Vitamin K intake from food sources is predominantly in the form of K1 from mostly green leafy vegetables and some plant oils. However, the form of K2 sources can come from both fermented foods or via biosynthesis of our gut microbiota. At one point, it was thought that the gut bacteria contributed to up to 50% of vitamin K requirement of the host. However, there is no known mechanism of vitamin K absorption from the colon. Vitamin K2 produced by the gut bacteria may instead contribute directly to human health, though through supporting gut microbiota diversity. Dietary vitamin K1 may be an influential factor in these dynamics. Several bacteria are known to also synthesize certain B vitamins, even though water-soluble vitamins are plentiful in our diet. But what's interesting is the molecular structure of bacterial synthesized vitamins is not always identical in the dietary forms of the vitamins. We see a reduced synthesis of B vitamins in individuals with specific disease states and even malnutrition. So let's take a look at some of the research here. with regards to home blenderized tube feeds and improvement in gut microbiome in children dependent on enteral nutrition. So this is a pretty recent study from 2023. Although relatively small based on the exclusion criteria, there was only 13 of the 25 children qualified. So 6 of them received home blends and 5 received a ready-to-feed formula. They obtained saliva and fecal samples to evaluate both oral and gut microbiome profiles. Now the results showed distinct microbial differences between the oral and gut microbiomes between groups. While the oral microbiota varied slightly but significantly between the groups, the gut microbiome composition differed more notably. The home blend tube feed group had significantly higher microbial diversity in the gut. And a PCA analysis revealed variations in the microbiome composition of saliva and feces, indicating that the microbial communities in the mouth and gut differed markedly. The overall number of observed microbes was significantly increased in the home blend tube feed group in the gut microbiome, while the oral microbiome were comparable between the two groups. Now, most studies on home blend tube feeds have focused more on nutrition and medical values, but this study specifically shows that diet is just as important for the effects of gut bacteria and microorganisms. Here we have a national multi-center retrospective chart review. In the pediatric population, interest is growing in the use of blended diets for the management of enteral feeding intolerances. The aim of this study was to collect data relating to feeding tolerance in children who had switched to an enteral formula with food-derived ingredients. So dietitians collected information for about 5 months in 2021 from 43 medically unwell children. And as you can see from the outcomes, there was a significant improvement in GI symptoms, among other things, like improved behavior and even changes in their skin and hair. There was even improved weight gain, was listed as a secondary outcome, despite an insignificant difference in daily calories following the formula switch. As a result to the transition in enteral formulas with food-derived ingredients, there was a significant improvement in GI symptoms, including reduction of retching, flatulence, and vomiting. Clinical improvements were all reported within the first week of switching to these new enteral formulas. Fiber within a blended diet stimulates the growth of beneficial gut bacteria, which in turn produces short-chain fatty acids, which are utilized as energy substrates for enterocytes and acquired for a more diverse microbiome. The increased viscosity of the blended diet also reflects a more normal patterns for food consumption, in that the digested chyme reaches the small intestine at a pace that stimulates a more typical hormonal response. So it looks like we have some time here to really dive into some practical problem solving and case studies. So I have about 4 case studies here that we can review. And again, since I'm a pediatric dietitian, all of these case studies are related to pediatric populations, but we can definitely extrapolate to the adult population as well. So just kind of for the sake of time here, I do want to mention, I'll talk a little bit about how I implement the transitions to whole-based foods, tube feeds, but I really always like to keep in mind how to practice when it comes to the unique individual. So I really would love to say I have an algorithm to follow for each of these transitions, but again, it just depends on what this individual needs and what this family needs as a whole. But in my opinion, it's always more advisable to practice kind of a low and slow approach when it comes to a transition, meaning there isn't really a reason to get to our goal in an X amount of time. Rather, the goal is really improved GI tolerance. So often I start my patients on a 3-to-1 ratio, 3 parts being their current formula, and then 1 part being the new formula. And that's also kind of for the sake of the simplicity for the caregivers, because really we don't need to make tube feeds more complicated than they need to be. This low and slow method also allows for them to make gradual adjustments to tolerating fiber into the routine, because we know that an increase in fiber too quickly can cause some GI disruptions as well. So like I said, it doesn't have to be a sprint. It's usually, I'm advising the progression to the next step about every 3 to 5 days. So this gives them that window to determine how their child is responding to this transition and when the caregiver feels ready to make the step to a 1-to-1 ratio. And then we do a 1-to-3 ratio, and then finally 100% of the whole food blend formula. Now, let's talk about this patient here. So in our case study 1, I thought I had a different slide here. We have an 8-year-old with cerebral palsy. He's been G-tube dependent for quite some time. A lot of the patients that I see that have cerebral palsy are able to meet their needs by mouth up until a certain period of time, until they really start to reach school age where their growth needs are a little bit higher. So he was primarily supported on a pediatric polymeric formula, 1.0 formula through his G-tube, and just taking some purees, supporting a little bit of nutrition, but mainly for pleasure. Now, after several years of taking this same formula, he started to develop some pretty significant GI intolerance, mainly a lot of vomiting. And you know, when I first started working with this patient, I didn't know about the gut microbiome to the extent that I know about now. So really, it was puzzling to me and puzzling to the family as to why he was developing these GI symptoms after, you know, pretty much having this same diet for quite some time. So learning about the whole food blenderized diet formulas and kind of having that background, we decided that we wanted to switch him to a commercial whole food blended formula. And over the course of several months, we were able to fully transition, and the outcome for him was significantly reduced vomiting. Now this 3-year-old, he has a history of prematurity, autism, and poor growth. And the primary reason for his nutrition support was pediatric feeding disorder and dysphagia. He was supported on a pediatric polymeric formula, a 1.5 formula, just because of his high nutritional needs. Again, he was experiencing a lot of vomiting with his feeds, and despite that high calorie formula, he just wasn't growing. So the thought was, he's not growing because he's not getting the volume of nutrition because of all this emesis. So I worked with the family, and we were able to gradually also transition him from off of his polymeric 1.5 formula to try a commercial whole food blenderized formula. And we ended up having to also include an energy dense protein free supplement to support his energy needs even though we saw a overall reduced vomiting. So what wasn't noted before this change by the caregivers was his stooling patterns. So like most caregivers, they just assume that the baseline stooling patterns are going to be about the same. But with the whole food formula, families, the caregivers did report a significant improvement even in his stooling patterns, which originally wasn't what they would consider a problem. But with the reduced vomiting, we saw an improved growth, and now he's thriving on this whole food blended formula. Now this individual, he is a preteen. He also has cerebral palsy. He has a history of poor growth requiring hospitalization. Again, he was trying to meet most of his needs by mouth, probably up until this time that I saw him. So he ended up getting a G-tube to support his nutrition due to dysphagia and just the inability to meet his energy needs by mouth with the cerebral palsy. So he was still drinking some liquids and taking some soft foods, but also being supplemented with an adult polymeric formula. And probably about several years later, maybe 2 or 3 years later, mom reported an increase in issues with reflux, abdominal distension, and fluctuating bowel patterns. So there would be times mom would mention he's having a lot of constipation, he's going several days without a bowel movement. Other times he was having loose stools. It's hard to know based on mom's reports whether this was like encoparesis or due to like the constipation, or if it was actual like diarrhea. So over time, with all of these GI issues and just kind of some of his other health related issues, he really stopped consuming a lot of food by mouth, a lot of liquids and soft foods, and was really just dependent on that adult polymeric formula. So we ended up, again, transitioning him to a commercially whole food blended formula. And again, within a matter of maybe a month or two, there was a significant improvement in the symptoms of reflux. He had less distension. Mom noted that his belly wasn't distended like it had been, and overall improved stooling patterns. Now this final case study, a little bit different. So this kiddo is 2. He also has a history of poor growth. He's got a history of reflux esophagitis, pediatric feeding disorder, and the G-tube was primarily for nutrition to support his dysphagia. He was drinking some liquids and only taking tastes of foods, but these liquids just weren't supporting his growth. And unfortunately, even after the G-tube was placed, for this individual, the home healthcare company wasn't, or excuse me, their insurance company wasn't going to be covering the enteral formula. So mom had been purchasing this pea-based peptide pediatric formula and decided, you know what, let's try something else. So because of his frequent reflux and emesis, she felt like he wasn't tolerating this formula as well. So again, because insurance wasn't going to be covering the formula, we decided to try a home blenderized food. We used a blended tube feeding recipe builder to support both macro and micronutrients. And as mom was working through this, we were doing the transition. She was just recognizing the time and effort that was really, really required of her to make this possible. It's one thing to prepare a meal for your family, but it's another thing to have to, gather these ingredients just for this specific child when you have another child at home that you're raising as well. So despite the fact that insurance wasn't going to cover the blended formula, mom decided just to purchase the commercial formula out of convenience and ease, and she felt like the cost was well worth it because of the time that it was taking to formulate these home blends. So once we were able to transition him fully to a blenderized tube feed product, and I'm assuming that we would have had the same outcomes if she maintained the home blend tube feeds, but in this case, we were able to transition him fully to the commercial blends, and we also saw an experienced and improved growth and overall reduced vomiting. All right, so it looks like I was able to save a little bit of time, Laura, for some questions and answers today.
No, that's great. Thank you so much, Leila. That was really a lot of great case examples and things. So we do have a few questions that have come in, and we have about 8 minutes. So the first one is, what are some key factors that should be considered to minimize potential side effects during that transition phase from, say, a polymeric formula that has minimal fiber to any of the whole food, either homemade blends or commercial blend options?
So to clarify, so what are some considerations to consider just while we're transitioning, why we don't just up the home blends right away or the commercial whole-based food products? So the main reason, and we know this from when we talk to individuals about increasing fiber in their diet. So because there are GI symptoms of when we increase our fiber intake too much, we can also experience some negative gut symptoms of bloating and abdominal distension, because our gut has to, those microbes that have been fed other things are feeding off of this new food, and so that can cause some bloating, abdominal distension, some real discomfort. So we kind of do that low and slow approach so we don't end up having more negative side effects or outcomes. And that also allows the body time to move that new formula or that new fiber containing food further down and create that nice healthy bowel movement.
And do you feel like with your patients, with time, some of that distension and some of those bloating resolves once the gut adjusts and just takes time?
I find that we don't tend to have too many of those problems when we do it low and slow. If we, there have been times where, families want to just kind of transition right away, or there's been times where, maybe they run out of the formula product that they were using before the transition. And so there might be some of that, but over time, to make that point, over time, the body will adjust to that.
Okay. The next question is for reimbursement. In your patient population, and maybe I can speak more to this as well, but do you need to show intolerance to a standard enteral formula before you can get those whole food options covered?
That's a good question. Originally, I was trying to show, you know, hey, they didn't tolerate this. And I know that that's kind of been taught to us as why we need to try a polymeric formula first. But I've actually had pretty good success working with dietitians from enteral companies, and a lot of them no longer require those that information. So just,
Okay.
you know,
Yeah, that's
go ahead.
it's similar to what we've been reported to. It's very insurance based. Some insurances do, some insurances don't. I think it's less of a problem in the pediatric world than it maybe is in the adult world, but most experiences that I've had is, you know, any type of diarrhea, constipation, bloating, reflux, and ultimately what most tube feeding patients have one of those at any given time. So just documenting it's probably in your note anyway. But I do think it's gotten better with time, to your point. Okay, with some of your patients with neurological disorders such as autism, when you switch them over to a whole food option, do you see any improvement from a verbal or neurological capacity standpoint, since there is going to be a change in that gut microbiome, which we know then is, you know, the second brain essentially?
Yeah, I, you know, I haven't had too many patients with autism and tube feeds. I did have that one case. So I think that there's probably potential, but it's really hard to say based off of one individual. You know, and I think that with this individual, you know, he's 3, and so, you know, some of those things, that those behaviors and moods, I think it's kind of maybe too early to point out. But you know, that's what the science shows us, is that you know, a change in our gut microbiome can be beneficial to our enteric nervous system. So you know, if whatever we can do from a diet based to support that enteric nervous system can be beneficial.
Yeah, no, I agree. I think what I'm hearing is that to the audience member that asked the question, that is a research opportunity. I think
Absolutely.
that's a great question and really, really interesting. Do you have any resources, recommendations, guidance for where clinicians can find homemade, like quality, quantitative, homemade blended formula recipes?
I do. I don't know if I'm able to like, you have to tell me, Laura, am I able to like share names, or how does that work?
That's you just share what works for you in your practice.
Okay.
So
Okay. So Nestle does have on their website a recipe builder created by a dietitian. I want to say she's out of Boston. So I have used that one. What I like about that one is, you know, with this individual that we use this on, you can formulate things so you can still manage to get the right like macros and micros, but because he had some volume sensitivity and intolerance, I was able to find foods that were a little bit more nutrient dense. Where you know, if you're going off of just like looking at macros on your own, it's really hard to determine like what kind of volume you're going to get out of these foods.
yeah, no, I agree. And it at least gives you like a starting point, and then you can tweak things
Right.
um, based off of preference or cultural reasons or whatnot. So,
Yeah.
um, okay. And the last question, and I honestly don't know the answer to this question, so maybe you do. If not, we might have to get back to this person.
Okay.
Um, is vitamin K2 ever added to tube feedings? I don't think so, but I'd have to double check. I think it's always
I
K1.
Yeah, I think for the most part it is K1, and I want to say I'll have to double check my slides, but I want to say I saw it on in one of the in one of my research things. I want to say that I saw it, but it could be that it was just K1.
Yeah, so we'll get back with you on that one, because I don't know off the top of my head, and I don't want to say I
Yeah.
don't want to give you a gut response.
I will probably say historically, um, it's always been K1, but I'm sure with just some more emerging research about how important K2 is to support, making sure that calcification stays within our bones and not within our gut, that could be a factor. So
yeah, I think vitamin K is one of those vitamins we thought we knew a lot about, and then more recently, maybe we don't know as much about it as we thought we did, and we're really learning on it. So similar to like what vitamin D was maybe 10 to 15 years ago, I think vitamin K has gained a lot of popularity. So it's a really great question to the individual who asked that. I will follow up with you on that. So that brings us to time. So again, to everyone listening, you will get an email from my team at by the end of the day with your certificate, a copy of the slides, and the references to this. We will eventually be able to offer this in a recorded version for credit as well. That turnaround time typically takes about 3 weeks, so that I can get all that completed and on our website. But we do have Leila's other presentation she gave live a few weeks ago on our website for credit, so you can check that out. And then we have upcoming webinars available if you go to our website and look at those as well. So Leila, again, thank you so very much. Fantastic job. It's always a pleasure working with you. And to Fred and the You Deliver Medical team, thank you again for your co-collaboration in offering these 2 webinars. You guys do some great work over there, so I'm excited to keep collaborating on things. So, and to everyone, have a great rest of your day. Truly appreciate everybody's time. So, see you. Bye, y'all.